wait a second because some people are still writing down that stuff, which is cool. Yes, keep down, please. Getting crazy. Are we good? Are people done writing? Still writing? Where are we at? Okay. What? Thank you. Okay, so, first of all, I mean, how can you tell this is different? Like, what do I notice right away? That's true. What did you do? Yeah, like, I mean, literally that's what happened. Like, we were doing this before, and now we're just doing this. So it's hard for some people to, like, switch their brain to sideways. But what I see up here is this is solved for x, and in terms of y. And this is solved for x, and in terms of y. And so when I'm in terms of y, that changes the deal, because now everything I put in my equation has to be a y value, where before everything has to be an x value. So we are not looking top minus bottom anymore. We're looking right minus left. So let me see if I can convince you of that. That 10 minus 6 thing we did. Yeah, here we go. Here, let's say it's 1, 2, 3, 4, 5, 6, and 4. How far apart are those? Who just said 1? How? What? There's one tick mark? Is that what you're... Okay. So those are 2 apart from each other. How did you come up with 2? 6 minus 4. How far... Yeah. How far apart are 4 and negative 2 from each other? 6. How did you come up with that? 4 minus negative 2. How far apart are negative 2 and negative 5 from each other? 3. Well, isn't that negative 2 minus negative 5? Which would be plus 5, and those are 3 apart. So when you're looking horizontally at a graph to tell how far apart 2 points are, it's right minus left. Always. So that's the equivalent of, we were doing top minus bottom whenever we're in x's. It's always top from the top to the bottom. How you read it? Well, in terms of y, you read it right minus left. So, I don't know. I mean, I can kind of figure out on this one, but I'm not always going to know which one's on the right and which one's on the left. Remember, it doesn't really matter, because if you're wrong, what happens? It just comes out negative, and so we put the absolute value bars there, and we're just going to take a positive answer of whatever we get. So, these now become the endpoints of my integrals. So it used to be x equals because I was looking up and down and I need left and right boundaries. Now I'm looking sideways, and if I'm looking sideways, I need a bottom boundary and a top boundary. And there might be something in between them. So the first thing we're going to do, and we have a graph, but let's pretend we didn't. So go to solver and do negative y squared over 2 minus 4y minus 9 equals negative y over 2 minus 4. And then you're going to put comma y instead of comma x. And and see what we get. It should be -5, just look at the graph, but let's double check it. So you type the y's, just like, I mean, they're just y's. Calculator's fine with that. You just put comma y at the end instead of comma x. Syntax error? Well, then you are making a syntax error.
I know that much.
Wasn't that super helpful?
I told it. IT pro right there.
What?
IT pro right there.
That should have been an IT. All you have to say most of the time is when you start your computer. It still didn't work. Try again. Buy a new one. So I don't know what your error was, but here's what you should be typing. So solve, so then you just type it in the equation, equals the other one, comma y. You guys get -5 and -2? Okay. Does that help you see what your error was?
No, because it looks like I typed in the same thing.
Good, okay. Isn't it -y squared over 2? Minus 4y?
Yeah. Did I not do that?
Well, it's not syntax.
Yeah.
You put a minus in instead of a negative. Alright, so those are the intersection points. So remember, first of all, if I had gotten an intersection point of like -10, what would I do with it? I would ignore it, I would throw it away because that's not in between the y values that they gave me. I got two answers, -2 and -5. -2 I was already going to use anyway, so that doesn't really matter. -5 is new information. So I have 3 intersection points. If I have 3 intersection points, how many integrals do I need? I need 2, like first to second and second to third. So I'm going to integrate from -7 to -5. And I'm just going to gotta pretend I don't know which is which. So I don't know what the right and the left is, so let's just do it and see if we get a positive or negative number. So I'm going to do the y squared one on the right minus the other one, and when you put this in, everything's y's now. So do the y's and then put comma y instead of comma x, and then comma -7, comma -5. Then if you're writing it out, you technically get your absolute values there. Yeah?
Just to clarify, in our calculator, you're just plugging in y to keep it the same with what's on your page, right?
Yeah, so technically if you did all of this in x's, you would get the exact same answer.
Alright.
I'm trying to keep it consistent.
And then follow up, and this might be a wait till calc in college question, but could you do the same process around the z-axis? Rather than x.
Yes. Yes. And wait till college. So both of those things. No, but I remember doing that. And you can do them around like slant axes too. So like I could draw a horizontal, or like a diagonal line here. And like flip it around that if I really needed to.
See, I just had images of Tracto axis that is the angle to x, y, and z, and trying to flip it around there.
You can do that too.
That'd be
Have fun with that.
no.
Then I'm going to go from -5 to -2. And again, I don't know which one's on the right or left. I don't really care. I can figure out if I cared enough. I just don't, because it's so easy to fix if I'm wrong. So one of those should come out negative. One of those should come out positive. You take the negative one and make it positive, and you add them up. telling me 79/12 on the back here. See if that's what you get. See the over yet? Yep. So we got decimal. That's like 6.5-ish, 5.8. Somebody need help? Like, just have you walk around looking at people. So down here, you got all these y's, your equation, and then you put them x's. So you gotta keep the variables. Should fix it. Everybody else need to look there? Or got it? See? No. I don't want to talk to you unless I have to. Any questions on this first one here? We are? Yeah. So you can, while you're waiting, if you want to keep going or whatever, I want to do one without a graph next. So I'll probably jump to like number, no, 6 is a little easier than I want. All right, let's do 11. 11 doesn't look scary. So I'm going to go to 11 next. If you want to go to 11 with me, great. If not, it's up to you. I know what you're talking about, but do you know what a swirly is? Do you guys call them? Maybe that's like when I was a kid. Swirly is like when you shove someone's head in a toilet and flush it.
Yeah.
That's still a thing people say. No. I don't know if that's a culture you really want to be a part of. Alright, let's look at 11. They're swirlies. So when you go to solve it, that's the first step, right? Is to go solver 2 sine y equals negative sine y, comma y. And so I think the numbers can change, but like mine gives me this at n1 times pi. But I think the 1 isn't necessarily always a 1. You got n4, n2. So I think if I just like did this over and over again, the n just goes up. Yeah, like the next time I do it, it's n2, and then n3, and then n4. So that doesn't really matter. What that's telling you is these intersect every pi. So they're going to intersect at negative pi, at 0, at pi, at 2 pi, at 3 pi. Like they just keep going. It's one of the like wiggles. And so every pi they intersect. So we know they intersect it. So we got negative pi. If I add pi to that, like the next time they intersect, where am I? I'm at 0. So I got negative pi. I've got 0. My next intersection, if I'm going like up by pi at a time, would be what? Would be pi, but does that one matter? Is pi lower than 2 pi over 3? Is pi less than 2/3 of pi? Can't be, right? So the pi, I don't need, because that's like beyond r. So if I were kind of drawing this out on a number line, negative pi, 0, pi, but 2 pi over 3 is 2/3 of pi, so that's like somewhere in here, and so I don't care about anything past that. Does that make sense? That's what that at n thing means. It just means like there's there's really an infinite number of solutions, so your calculator's not going to list them all. Yeah? Good question. What is yours? Are you in degrees?
I mean, mine is 180.
So then it's the same idea. They intersect every 180 degrees, which is, so you can do it either way. So how many intersection points do we have to work with? We have 3, right? We have the negative pi they gave us, the 2 pi over 3 that they gave us, and the 0 that we found. So we need to integrate from negative pi to 0, and we need to integrate from 0 to 2 pi over 3. And then beyond this, the fact that it's trig doesn't really make your life harder, I don't think, because you just type it into a calculator now, right? But getting those two set up is tricky. So again, I don't know what's on the right or left. I don't care. I'm just going to guess. And absolute value at the end if I'm wrong. Now it does matter though, Dustin. So when you're typing it in, you want to be in radians. Because if you type like negative pi to 0 in your degrees, it's going to throw it all up. I guess you could do the whole thing in degrees too. I think radians is easy. So you find those 2 parts and add them up. There's not always 2 parts. I just picked 2 that add 2 parts because they're the tougher ones to go through with you, but sometimes there's only 1 part. So this one says 10.5 for an answer. Yeah.
Need units if it's a graph.
I didn't know what the units would be. Numbers, but you can talk about that. So let me back up. I should have started the problem with this, but let me just talk about this for a second to make sure we're thinking about this. Why, when I looked at this problem, did I decide I was going to do the whole problem in Y's and use right minus left instead of doing the problem in X's and using top minus bottom? Yeah. It's solved for X. I mean, that's really that little. You got to look for it, and you got to know what you're looking for. But if you see solve for X, so you can kind of think about it the other way. I would look at the equation part and be like, okay, there's Y's in it. The solve for X, I don't want you to get confused down here because these are solved for Y. You know? Yeah.
So on the last sheet we did, sometimes we had to like rewrite it because one of them was solved for Y and one of them was solved for X. Should we just look at the boundaries then and see?
Boundaries are good too. So if your boundaries are Y values, then you know you're going sideways because you got to be like within this.
Yeah.
Does that make sense? My little motion here. And if your boundaries are X values, you know you're going up and down because you got to be within this little. We can make like a calculus dance club or something. Yeah. That square should not be there. Why is that there? There's a chance I wrote it, but some people like mess with these too. Like try to screw people up. It's like math sabotage. I might have written it, I don't know. But if you were copying this down before, I guess there was a square there. This should not have been. There's no reason to square that. Yeah, so I apologize. I didn't see that. Or me to put it, I don't know what happened. But make sure you take the square away. That should not be a square. What is, oh, shoot. That's funny. Are we getting 10.5? How many got? Okay. So I think we're good. So I went through one with the graph, one without. Both of them had intersection points in the middle, so they're kind of the toughest ones. So I want you guys to start working and let me know if I can help you. Does it seem like you're good?